Hello everyone and welcome back to the Quant Philip and to the Quant Finalism as well. So a series in which we do a new concepts every day. So today we'll be doing geometry. Okay. Again, same thing. Join this group to get all these PDFs. Very helpful during for revision. Let's start. Okay. Before doing the actual question, we'll be dealing with two concepts, that is internal and external angle and hexagon. Okay. Hexagon is very important figure with respect to CAD after circle and triangles. Okay. This is the third very important figure since now these all circles and triangles have become cliched. So they have started focusing on hexagon now. Okay. Because the concepts remains the same. Only the thing is they give you variety of questions in this. Now let's do, first of all, we'll do is external angle and internal angle. Okay. Oh, so there are two formulas. So that is like, suppose if the number of sides is n, then each internal angle is equal to n minus 2 into 180 by n. Okay. Remember this formula is for regular polygon. Okay. Regular polygon, not for any polygon if they're not regular. Okay. Only for regular polygons. And each external angle is equal to 360 by n. Okay. Now see, if I talk about this hexagon number of sides are how many? 1, 2, 3, 4, 5, 6. Okay. So for hexagon, each internal angle, this is the internal angle. Okay. And external angle, like if this we extend and this we get. Okay. So this each internal angle will be how much? N is equal to 6 for us. So 6 minus 2 is 4 into 180 by 6. So 30. So 120. Okay. So this each internal angle 120. All these will be 120. Okay. Now external angle will be how much? 360 divided by n. N is how much? 6. So 60. Okay. In case you remember only one formula, then you'll be able to do this because we know that external angle plus internal angle is equal to 180 degree by linear pair. Okay. You can check that as well. Internal angle came out to be 120. External angle came out to be 60. So that adds up to 180. Okay. This is the formula and very important. One more figure I'm taking, like, and remember this is for like n greater than equal to 3. Okay. Because n is equal to 2, no figure is possible. Okay. You cannot make any enclosed figure using n equal to 2. Right. Very important formulas. Do remember this. Okay. Let's come to hexagon now, or let's come to hexagon. Okay. So one thing in hexagon, like suppose that the side of this is 1 and the side is 1. Okay. And you have been asked to find this diagonal length. Okay. This is the diagonal length. Okay. So how will you find it? Okay. This is very important concept. Might, like, the mock season has also started, so you must have already witnessed it in the mocks as well. Okay. So whenever you see like a figure like this, okay, a triangle, hopefully you can notice a triangle. Can I shade it? Just a second. Highlighter. Okay, yes. So I hope you have noticed this. Hopefully you have noticed this, what to say, this triangle, the red part which I have highlighted. Okay. So that particular part I have drawn over here. Okay. Now each angle we know is how much? N is equal to 6. So 6 minus 2 is 4 into 180 by 6. Okay. So 120 degree. Okay. Now we know this side as 1, we know this side as 1. Okay. This you have to find out. Suppose this is x. Okay. So whenever we know two sides and one angle. Okay. Remember, two sides and one angle when we know, and we have to find out the third side. Okay. We know and we have to find out third side. So in that case, use the formula called as, I'm erasing this. Use the formula called as cosine formula. Cos formula, cosine formula, what even do? Cosine formula. Okay. What is that formula? Cos of the angle enclosed, that is 180, is equal to squares of the, like, is sides enclosing that angle. Okay. It means that ये angle है, इसके साथ में जो sides है, that is 1 and 1. Square of those side minus square of the third side divided by 2 into these two sides, the enclosing sides. Okay. So 1 into 1. Okay. From here, you'll be able to find out the value of x. Okay. This is very important for, like, not only for this. Okay. This will be helpful in many other figures as well. Like sometimes for pentagon and hexagon, sometimes octagon as well. Okay. So very important formula is cosine formula. Remember this. In triangles, it will be very helpful. Okay. Please do remember this cosine formula. So two concepts we have done today. And now let's do the question as well. In the figure below, ABCDF is a regular hexagon and AOF is 90 degree. FO is parallel to ED. What is the ratio of area of triangle AOF to that of hexagon ABCDF? Okay, so this is the hexagon ABCDF and this is O. Okay, we have to find out the area of this with respect to total. Okay, we know that this. Okay, first of all, let me join this. Okay, this is a straight line. Remember, okay, and this is a regular polygon. Okay, this I have straight. Okay, so as I told you, the exact formula which I told you right before, this formula which I told you, I guess we can use the same because this is exact same thing only given. Okay, so we can find out the area of this figure. We can find out the area of this complete figure, and we know that since this is exactly in midway, so area of this smaller figure will be half of this complete figure, right? So area of triangle AFE is how much? Although you can do one thing there, like it is given and this is 90 degree. So we can find out the value of this AE using the formula stated over here. Okay, let us find out. Cosine formula we have to use. We know this angle is 120 degree. Okay, and suppose these sides are 1. Okay, because it is given that it is a regular hexagon, so we can suppose the value. Suppose these are 1, so this is x. Okay, so cos 120 degree, as I told you, this is 120 degree, and sides enclosing that angle 1 square plus 1 square minus, suppose the third side to be x square divided by 2 into 1 into 1, right? So cos 120 degree, this thing you have to remember. Okay, please remember this. ये formula like cos 120 degree value याद कर लो, बहुत काम आती है, is equal to -1/2. Okay, so -1/2 is equal to 1 square plus 1 square is how much? 2 minus x square divided by 2. So this gets cancelled, and 3. X square is equal to 3. Okay, this we got as 3. X square we got as 3. Now, what will be the area of this smaller triangle if you see? Half of this complete triangle area will be how much? Half of base is this complete x. So half of base is x, and height is what? Height is this particular value. We can find out. This is how much? This is root 3/2, and this is 1. So this we can find out. Okay, this we can find out how. This is root 3/2. This is 1. So 1 minus 3/4. This will be 1/2. Right? 3 plus 1, 4/4. I don't think so. I guess it's some error. 1. This is 1. 1 minus 3/4. 4 minus 1/4. And this will be 1/2. Absolutely. 1/2. Okay. I hope I'm not mistaken anywhere. We added root 3 square, 3/4 plus 1/4, 4. Absolutely correct. Okay. So this is 1/2 we got. So area will be what? Half of x. X is root 3 by x is root 3. And height is 1/2. So we got this area is to be root 3/4. Okay. So this complete area is root 3/4. So smaller area will be half of this. So root 3/8. Root 3/4 half, root 3/4 half is root 3/4 half is root 3/8. Okay. Now we have to find out the area of hexagon. Area of hexagon formula is pretty straight. It is 6 into root 3/4 a side square. Okay. So this is how did we came. We know that hexagon has 6 equilateral triangles. Okay. 6 equilateral triangles. So 6 into root 3/4, 1 square. Okay. So this is we got 6 root 3/4. Okay. Now we have to find out the ratio area this to complete. So root 3/8 divided by 6 into root 3/4. So this gets cancelled. This is 2. 1/12. Okay. So 1/12 is the answer to this question. Okay. This is a lengthier way of doing this. Okay. 2 more ways of doing this. Okay. First way I have told you like this. Okay. Why have I told you this way? Because this is important concept. Like questions will always be not that straight, which this question is going to be turning out to be. Sometimes the concept you will need it. Okay. So this we got answer is 1/12. Okay. Now one thing we can do now is we can do construction. Suppose if we join this. Okay. This if we join over here. This if we join over here. Okay. Now this if we join. Okay. And this if we join. This is, if you carefully visualize, this is what? All these figures, like smaller triangles, I would say, are all these triangles. Okay. And one more we have to draw from here. Okay. So what we did is we basically since the figure is symmetrically, so we basically bisected the figure in equal areas. Okay, all these figures will have equal area. Okay, this method can be used in exam scenario, like if the question turns out to be first time, can only be done if your visualization is awesome. Okay, then only you can like bisect this figure in all of equal areas. Okay, if you carefully observe, like this is if we suppose this to be some area, इसे हमने half किया फिर half किया, so automatically both of these areas are equal. Okay, similarly other processes is done, so all of these smaller triangles, जितने smaller triangles दिख रहा है सबके area equal. Okay, so AOF, if I give each of them area as 1, so AOF is 1 divided by how much, 1 2 3 4 5 6, so 6 ऊपर का 6 नीचे का, so 12. So the answer is 1 by 12 is the answer to this question. Okay, super awesome if your visualization is good. Okay, and if you know the concept, वो भी बहुत काम आएगा, no issues in that. Okay, and one more way of doing this is like this. Okay, let me see. If we extend this, and this we know is 1, this we know is 1, this angle is 120 degree. Okay, area of triangle AOF is half of, if you know the formula, 1 by 2 AB sine theta. Okay, if you know this formula, then also you can do this. 1 by 2, 1 into 1 into sine 120, 1 into 1 into sine 120 is root 3 by 2. So you got it, root 3 by 4. Okay, so this complete area is root 3 by 8, 4. So half of it will be the value of this. So this is root 3 by 8. And as we did previously find out, that area of hexagon is how much? 6 into root 3 by 4 into 1 square. 4 will go over here. This gets cancelled. This is 4. So 1 by 12 is the answer. Okay, so 3 ways of doing this question: cosine formula, and bisect symmetrical, whatever you want to say, and sine, area sine formula. Okay, so I hope you found this meaningful, and 3 concepts you must have learned, that is cosine formula and area using sine theta. Okay, that's it. Thank you, and once again please join this to get this PDFs. Thank you.